I have my half-inch tool capacity boring heads lined up here on the Moore number 2 jig bore. Let's have a look. You're gonna have to excuse me a little bit. I am hoarse. There's smoke in the air, and it is like 100 degrees out there, 99. Really hot. I'm not really active out here right now, but I just come out I can come out and do a couple things every now and then. I'll start with the Moore head here. Now, this is kind of a standard design, and a lot of manufacturers make boring heads like this, and it's kind of got a thing in there inside the body, so this thing moves back and forth, but it has very limited range, but it's very accurate. And there's a couple of styles of these, I guess 3 styles, and this is the best one here with the 10,000ths Vernier. Now, there's a lot of other boring heads out there that are manufactured today that work pretty much the same, so they can be purchased. Now, these Moore do not have a removable shank, and I think at Moore they think it's preposterous anyone would remove the shank. The fact is, this head here converted to use on other machines will not give you really a distinct advantage like you'd have with a real jig board. It's not going to get you much into the ballpark here. Now, here is Criterion. We're talking some older stuff now. Okay, they got it. Other versions of this. But this is a 10th setting Criterion 202, 2-inch head, and it's got this device here at the base here that reads in tenths 02 30 tenths, 0 to 30 tenths. So you loosen the locks and you turn this, and it must be aligned with that mark right there. And so you can kind of filter in tenths into what you're doing, but it sort of doesn't work real easy. It's like you need to do a couple test holes kind of thing. Not like the Moore head here that you can work with tenths while you're going. I don't know, it's kind of hard to explain, but this device didn't sell very well, and I think these are really quite a collector's item. Yeah, for no good reason. Kind of, to me, I think they're interesting, but they're kind of disappearing off eBay, and I'm not sure when they quit making them. Maybe this early 80s? I don't know. Okay, this is, and this device here detaches, but they sell them as a unit, because when you screw this on to other heads, that important mark might not align with the dial, then it won't be accurate when there's cam mechanism in here. It's sort of like the spindle shank and the head are separated. Then this thing kind of clamps it together, then cams it here, so there's 2 pieces here, or 3 or whatever. I haven't taken it apart. I'm not up on taking things apart that ain't broke. Now, the one thing I wanted to point out, this is the most common type, 2-inch boring head. This is a genuine Criterion. And I tell you, one of the things I don't like about them and why I like the square heads better. Though they're perfectly fine boring heads. But this is a 2-inch square. Look at the size of the dovetail on that thing, and look at the size of the dovetail here. So if you look at these things, this is their, I think, one of the smallest heads here. And it's an 1.5-inch head. And you can see that the dovetail is even greater than the 2-inch round head. I just thought I'd point that out. I run into some difficult casting repairs where the castings have been re-welded, and it could even be cast iron castings along with aluminum. And with the cast iron you could run into hard stuff. And the most rigid setup you can get is going to be the best. But one of the things you can do, one of the people don't like these square heads, is build boring bars like this. Like this is a purpose-built one for the repair of a Harley Davidson crankcase. I did this years ago, and I probably used this 100 times. And what it does is I can get a better, it's a bearing tool, fitting tool, and I can get a better finish with it because I can run it faster because it doesn't have the offset going. So I hope you can hear me here. Clear my throat a bit. I thought I'd better check in and do a little bit of a video for fun. Okay, so to help keep tools in the boring head straight in the head, so the head doesn't have to offset, let's say, more than that. You know, these things really offset. And you can make tools for your holes that you're, you know, mostly cutting. And so you can reduce that offset. And like I say, without that offset, you can run this thing a lot faster, get a better finish and more accuracy most of the time. Okay, so I showed how the more jig bore head, boring head works. And there's the later Ericsson, and there's just a whole bunch of other boring heads that have the vernier here now. They'll cost you $600 used. Yeah, that's about it there. And I'm going to show how I offset these bars. You see, I can use this on a bigger hole, and that's just a 1/2-inch piece of steel. We're talking about the 1/2-inch head here and using 1/2-inch shanks. You can take and bend the head, see? Put a bigger piece of carbide on it. See that one? Kind of goes at a hook like that. That way I can have that large piece of carbide on there. Okay, I'll show you how I bend that. Okay, right here is the reason that I use these automatic facing heads and have to make special boring bars. Now, this surface here, by the way, this is the inside of the cam chest of a very early Sportster type motorcycle called the K model. This one here being 1953. Now, these things can break. There's like the main shaft, right hand main shaft comes out this side, left hand out the other side that has a sprocket on it to drive the transmission. Now on this side there's 4 cams with spur gears on them. And things can go wrong, a shaft can break, and all of this stuff gets broken out. Now off the cam 4 here, there's kind of a larger gear outer here, and that drives this idler wheel that runs the generator. Now things can go wrong in the generator. The something could get stuck and bust the drive wheel off, which is on a short stud here. Then you'll find yourself having to find a very good heliarc welder to build this area up. And then you do your part as a machinist. And if you can see this, this is factory, it's never been broken. It looks like it's lathe turned. They had a cutter that came, a pilot cutter that came down in a rotation and finished that to the correct height and the bore here. So you can find yourself completely busted out here or partially and get it welded up very good as possible. Then you can come in with your automatic facing heads and actually duplicate this whole thing here. And you do such a good repair. The only thing you'd notice is the metal looks a little bit different here and there. And that can happen on old cases anyway. So all this stuff can get busted out, and a good welder can weld it all up. And you just start machining it, and you can reproduce these things that were done with cutters that would take you an entire day to make, probably a cutter that size, or you'd have to adjust a face mill in the cutter grinder to get the right size. I checked that out before. It's just easier to, and they change a little bit. So you can see what's there, get it welded up, then come in with the fancy born heads and your custom tooling and restore it. And sometimes this whole ear here gets busted off from a front end collision. And this can be welded back on, but then everything's distorted and you have to use your layout skills to relocate this so it'll run the generator. Okay, so this was the basis for this knowledge that I gained to make cutters like this, okay, boring cutters. And I had to pay a guy to show me how to run that jig boring machine, and part of it was this cutter stuff that I'm showing you for free. So okay, we'll get up to got a little vise work to do up there. And now the value of these engine cases can be extremely high. And if in the case of something like one of their racing models or something with a race history or something like that, you know, if you can, and they get busted up, I'll tell you what, they blow the transmissions out. I've showed a lot of this stuff on here, and I'll continue with it as I can. Well, anyway, back to the vise, and I'll show you another trick with these boring bores. Okay, in this part of the video, there's going to be fire and all kinds of things. Okay, here's my good old Parker vise here. Had it for a number of years, picked it up at a railroad auction in Hermiston, Oregon. It's a Parker 6-inch with a rear swivel jaw, and it's in the raw, unrestored. I've done nothing but use it. And it's got, the jaws on this thing have been hammered, and whatever's here has been welded in, and here is the remnants of an original jaw welded in, and it works okay. But this is one thing I do to my, I guess you would call it my working vise close to the machines is I deburr the jaws. Just make sure there's no burrs on the faces. Give it a little touch across the top. Now this one feels good. I'll catch a few places. There we go. Okay. Now that causes less damage to just grabbing something like this. Now this is a piece of 1/2" 01 drill rod, and that little tit in the middle is the center. So when you put this in a boring head and you want a piece of carbide on it, the top of the carbide has to be to or slightly below that center. So this tool here is limited to how big of a piece of carbide I can put on it because of the straight portion here. So I'm going to offset this, and I'll show you how I do it. Now, I wanted to point out something right now. You see the handle on this vise here? It's got a screw or a bolt and a spring and a little piece of metal in there to keep the handle like that. You see that? So if vices that don't have that are just extremely irritating. See, with one hand, I got, how many hands you need to close the vise with, right? Should have a hand on the piece of work. So with one hand, I can propeller this heavy duty vise closed very quickly. If it did not have that, it would go clunk, flop. It would be of extreme irritants, of course. So, okay, so I'm going to stick this in there. Oh, it's going to be a little too much there. And I'm going to have it stick out. I'm going to probably waste a little bit playing with this. Okay, so that looks pretty good right there. Then you just slide this up and lean into it. Okay. It'll slightly deform that piece of drill rod, but I can straighten that out later. Okay. But if the jaws were rough, it'd make that a lot harder. I found out why my voice is so scrapey is because there's like air quality alert out there along with a heat alert. So this is a Victor set. I picked up 100 series, looks like, at a pawn shop in Butte for $90. I know you can buy the like from the importers and stuff like that, a whole set a lot cheaper than that. But I prefer to have this old American stuff, I guess. Come on, a little more. Hasn't reached through the whole shit. Here we go. No. I got a fire extinguisher right at my feet, and you should do that. I have no idea why it's not flowing through here yet. Oh, there we go. Okay. Come on. I got it. Okay, turn that up a little bit. Give it a little oxygen. Leave a little bit carburizing. Little feathers, That way it won't boil the surface, which I'll probably grind away anyway. So, I got my favorite hammer here, this D-swing. So here we go. Come on. I gotta rearrange stuff here. There we go, I need both hands on this. And we'll heat that up very hot. I could have used a bigger tip, couldn't I? I think this will do it though. I'll crank on a little more juice. I'll crank it on. Let me turn it on. But then I'm having a hard time figuring out which way I'm turning this thing. Okay, it's getting hot now. Okay, we're getting there. Okay, heat it up till about the color of butter. Okay, I'm going to smack it down from the top. Now I'm going to smack it over. That's looking good. I'm not sure if I want to reposition that or not, but I'll get it started. Probably going to be good. Make sure I get that hot. Get it hotter. Okay, I'm going to shut it off and reposition. I don't have a torch holder. Okay, here we go. Get it up. Okay. We can have a quick look at it. You see it's kind of mooshed out there. All right. All I need to do, get that vise back in the middle. See, this is where that vise handle thing really becomes a problem with a large vise like this. And you need a large vise like this if you're going to hit things like that, even a 1/2 inch rod. Okay. Oh. Well, I hope you're all doing well. It is extremely hot outside here. Turn up my grinders. Kind of overdoing it for a brazing tip a little there. See if we can heat that up. Yeah, when I hit it from the top, I knocked it down just a little too far on the vise. Okay, I'm confident now it will roll over a little bit. Not all the way though. Okay, I like the look of that, and we'll roll with it. I will be back. Oh, back here at the belt grinder, we'll clean up that mess I made on the end of that. I'll slow this down a little bit. Just kind of clean it up a little bit. I am wearing gloves around moving machinery, but I'm extremely careful. And plus, this gets real hot. Does a real fast, nice job. Okay, I'll get a little heavier duty grinding on this thing. Yeah, it's starting to look pretty nice. Okay, we'll take and gauge this and see just where we're going to place that carbide. Okay, we'll be right back. If I can shut the camera off. All right, back onto the boring bars. Now, this is an important thing of what I used to do. Now, these boring bars not only can be used in the regular boring heads here, they can be used in the lathe. Here I have a left-hand one in an ER32 collet chuck in a regular boring bar holder there, and that's very economical. And I can tell you, I bought this and the collets at a price point because it doesn't matter if they run out very much. So these are the very cheapest, and this was probably, I don't know, under 40 bucks complete with a few collets. So it works good for boring on the lathe. Now, one of the things I want to point out, there's a lot of people that don't know all these things, so I'll point it out. Now, on a lathe, you see I can raise and lower this right here. In the bore, let's say right there, then I can rotate this to center. I don't think I have that tight. Now, let's say I rotate that to center. I'm going to loosen that a little bit. Right about there. And say, well, I need some back rake. So what you can do there is lower it a little bit, then rotate it up to center again, and then you've got some back rake. Now, that doesn't happen in a milling machine boring head. There's only one center, and that's center of the boring head in the spindle. Okay? So you can't rotate this effectively for back rake without getting off center, and all kinds of things can happen unless you're intending to do that. So with the boring head and the milling machines and the jig borer, you have to figure in your back rake when you're building the tool. And that's one of the things I'm doing here is figuring in a little bit of back rake, top rake, side and back. Okay. Now this, along with that thought, since the tool shank must be on center. See, on center with the boring head, you got to find the center. So I got this little portable setup here you can bring to a workstation, and you can find center. Okay, I got that centered onto this 1/2-inch piece of tool steel. So I can bring this back around here, and you can see it's a little bit below center there. So I rotate it to center. It's kind of hard to see with this one. I think I should have a clamp on it. But I rotate it to center, and it's got a little bit of back and top side rake. And that makes it cut really freely, and you can adjust that for difficult conditions. So I can start cutting on something. Let's say it's a weld repair or something, it starts chattering. I go, oh man, I'll pull out another tool with less or more back rake, less radius, all that, you know, and you change all those angles to get it exactly where you want it. So this is the way I gauge it, and you can calculate. Let's try this other one in there, where this stuff's going to end up. So here's the tool we're working on here. This is the side I did a little while ago, and I'm going to select a piece of carbide, and it's got to be kind of a thin piece because I didn't offset or forge over the end like that. So we can bring this end that I forged around. Now, if it's pointing this way, let's say, slipped out of my finger. If that forge over is pointing to the left, then I can move a piece of carbide over for a bigger hole, keeping the head with less offset, see? And if it's going to be a left-hand tool, it would the offset would point to the right there. So what I'm going to determine, the way this is, I'm going to make a kind of a combination of turn here and get the ideal spot to put a hefty piece of carbide and have it offset over so I can cut bigger holes with this. Okay, let me get this back into the camera holder there. Now, you don't have to do any of this stuff. You can buy sets of cheap boring bars for probably less than 20 bucks. Okay, but one of the things that I do is I work on expensive things, and I'm trying to restore or make things work. I want the best tools possible. So here this is kicking to the left. Now I can take and rotate this down a little bit right about there, and that'll give me the enough spot, plenty of room. You can see how much metal I got hanging down there. I'll need to trim this a little bit better here. But I can get a good spot where I can put a thick piece of carbide in there and have it extend over to the left. And now, one more thing, it's just so simple, I got to show you. When you want to control your like your side rake here, you could call it, depending on which way you're cutting it, you have to put the carbide below center. Then you rotate, then you have to rotate the tool to center, and that gives you some back rake. Now, if you don't offset it, like this one, you have less option because there's not as much room, and you have to use thinner chunks of carbide. Okay. I hope you enjoyed that and understood some of it. I will be back. I've been making these boring bars for a while, and here's a tool here that's very handy. It's a crashed 3/4 inch ball bearing drill chuck. It's damaged pretty bad, but it works for this, and I can grab like these boring bars, get in there and hold them, and then I use a file to finish the seat there, and we're getting very close. So I'm going to take this back over here. Okay, now these are the basic tools, mostly for the standard heads, but they can all be used in the automatic heads too. So we'll set this up here, see how it's looking. And I got a big fat piece of carbide there. See, I got to file that into so it goes all the way back. Getting very close. Very close. I just got to settle down the back part of it a little bit, and then get it in the tool grinder. And I've made my own boring bars. Actually, they're well worth it to me. So I can just do a lot more with them. And getting that thick piece of carbide on there, you can change the top angles if you need to. Things you can't do with the commercial boring bar. Okay, I will be back with some welding because it's a little too hot to do it right now. So I'll catch you in another video pretty soon. Thanks for tuning in.